Chapter 2, Section 3. So you can graph to solve an absolute value inequality in the form f of x is greater than g of x, or f of x is less than g of x. F of x is your absolute value function. G of x is a constant function. So working with any absolute value inequalities, you can either graph them or you can solve them algebraically, which we're going to do both today. This is the last section in the chapter, so on Friday you will be seeing a chapter test. So looking at example 1, we want to solve graphically. So our function is the absolute value of x plus 3 plus 1 is greater than 4. So x from our absolute value to that inequality sign, this is my f of x function. And then my constant function is the 4, which is my g of x. Okay? So that's why f of x is greater than g of x. F of x is greater than g of x. So I'm going to graph 4 on this graph. And it's just going to be a straight line across the y-axis, horizontal line, because technically y equals 4. So that means that all of my solutions are going to be greater than that line for this inequality. So using our graphing skills, we know that 3 is my h and 1 is my k. So that means since 3 is positive in here, we are going to go over to 3 and we are going to go up to 1 and plot our vertex. So 3, 1 is my vertex. From there, it's just going to follow. There's nothing else that changes, so it's going to go over 1 and up 1. And we'll go over in the negative direction and up 1. And then we have our graph. So in red is my g of x function. In green is my absolute value function. So that means all numbers that are above this g of x function, this 4, is going to satisfy this absolute value function. Same thing in part B. The absolute value of x minus 2 minus 3 is going to be my f of x. And then 1 is my g of x. In this case, the absolute value of x minus 2 minus 3 is less than 1. So that means I'm going to graph 1. I'm going to graph my g of x function. Straight line going across. That will never change. Okay. This one, for my f of x function, h is 2. K is negative 3. So that's going to be my vertex. I'm going to go over 2. And I'm going to go down 3. And again, nothing else changes to, there's no A and no B, so there's no point in doing the work for the 1, 1 and the 1, negative 1 like we've been doing. So 2, negative 3 is my vertex. I'm going to go over 1 and up 1. And I'm going to go over 1 and up 1. And this will be my function, my absolute value function. So anything below the red line is what is a solution to make this inequality true. And that is graphing, solving absolute value inequalities by graphing. Example 2 is solving them algebraically. There's a couple rules to go over. It says if the absolute value of x is greater than a, where a is a positive number, then a is less than negative a, or a is greater than a, or x is greater than a. So let me read that again. If the absolute value of x is greater than a, where a is a positive number, then x is less than negative a, or x is greater than a. Rule 2, if the absolute value of x is less than a, where a is a positive number, then negative a is less than x, which is less than a. So 2 rules, just like when we were solving any absolute value equations, there's 2 rules for when we solve absolute value inequalities. So if we go ahead and look at this first part of our example, we have the absolute value of 4 minus x plus 15 is greater than 21. Same thing like when we solved equations, you want to get everything away from that absolute value. So I'm going to subtract 15 from both sides, have the absolute value of 4 minus x is greater than 6. From here, x, the absolute value of x, is greater than a. So I'm going to have this or this. I'm going to have that disjunction statement. So I'm going to pull that out of the absolute value. So I'll have 4 minus x is less than negative 6, because it's less than negative a, or 4 minus x is greater than 6. So then we go ahead and solve these inequalities like we normally would. Negative x is going to be less than negative 10. I'm going to divide by negative 1. And the same rules apply with dealing with inequalities. When you divide by a negative, you flip the sign. So x is going to be greater than 10. Or, same thing, subtract 4 to both sides. Negative x is greater than 2. Dividing by negative 1. And flipping the sign, x is going to be less than negative 2. Once we have our 2 solutions, we're going to graph them on a number line, just like you would any other inequality. So I'm going to put 0. I'm going to call this 10. I'm going to call this negative 2. So x is greater than 10, open circle on 10, and shading to the right. X is less than negative 2, open circle on negative 2, and shading to the left. And that is how you solve an absolute value function algebraically. So looking at the second part, we have the absolute value of x plus 4 minus 10 is less than or equal to negative 2. So in this, again, we want to get everything away from that absolute value. We're going to add 10 to both sides. I'm going to have the absolute value of x plus 4 is less than or equal to 8. From there, even though this is less than or equal to, it's still going to follow the same rules that apply. So we will have x plus 4 is greater than or equal to negative 8, because technically if we look back at our rules, x is greater than negative a. And this time it's an and statement.